Welcome back to another episode of Discovering Disruptions in Tech. I'm your host, Howard Holton, and I'm here with Brandon from Forward Networks. Hello, Brandon.
Hi.
We're at Black Hat. My bingo card only has one square right now, and it's agentic AI, because everybody's talking about it. But everybody's talking about it. So not just vendors, but everybody on this side is talking about it. So let's talk about shadow AI for a minute. Right? I know a lot of C-level executives writing policy for their organization that says, thou shalt not AI. I know for a fact those are all failures. There's just no way to do it. There's no way to tell 1,000 employees, 10,000 employees, 100,000 employees that are constantly pressured to get their job done, that they're not allowed to use this new magical tool that seems to be helping them, and have them actually not use the tool.
The best way to get an engineer to do something is to tell them not to do it, right?
Yeah. So
do you want AI? Because this is how you get it.
That's true. That is true. You know, we really didn't have any luck getting people to use this tool. We made it free for everybody, so now we have a policy that says you're not allowed to use it. Wait, I think I saw an email about that. I think I have that enabled. Right? So let's talk about that for a second, right? The problem with AI isn't AI, it's the shadow piece. The problem with shadow AI, I should say, isn't the AI piece, it's the shadow piece. The shadow is the thing we're not aware of. We spent a bit of time talking about things that are shadow IT-ish, right? How can people leverage virtual twins to deal with, recognize, understand their exposure to shadow AI?
Yeah, so a network digital twin isn't going to understand the full depth of every application that every user is going to. I think things like VPNs or some of the more, the newer browser-based DNS filtering, those systems are going to understand where users are going, and that's going to provide a starting point for what AI systems are getting reached out to. I think there's a broader trend of how do we know what AI is in use and how do we make it safe that we actually fit into, that a digital twin kind of plays into the story for. And so it isn't just what are people using, it's if they want to use AI with, say, MCP servers, not just going to ChatGPT. If we want the let's call it the follow-on use cases that aren't just a question and answer, that are relatively self-contained and controllable because there's a DNS name in front of them, so we can put a proxy in front of them, and there are multiple vendors that will sell you that. What about the use cases that are more bespoke, that are more internally generated, that a vendor sells us an MCP server? For those who don't know, right, this is a way to expose functionality data to general AI systems like ChatGPT types, or directly expose it to users who may want to combine them with scripts. And so there are also some vendors that are trying to secure the inputs to those, the outputs to those. I think where digital twin can be really useful is in providing really clean, trusted data to systems that want to make changes, especially to the network environment, or systems that want to get back to users. There's a ServiceNow or Jira ticket, and we want to fill in the gaps.
That'd be really interesting.
For IP addresses, we want to understand if this is a change that needs to be made, if this is a change that's safe, if this is a change that requires a higher level of access. So there's information in the digital twin about connectivity there that can help inform those changes for those who want to kind of...
You can almost create an MCP service for each network MCP service. Bear with me for a second.
We've done it.
Sure. So all of the requested changes first go through the virtual twin, confirm validity, confirm success, whatever the success is, return success before allowing the change to go through the actual AI for change.
I would love something like that too. The current reality is that the digital twin can inform, like, just imagine, right? You connect up every ticket and then it immediately provides context. Or you take every SIM event and you just ask the digital twin, what can you tell me that can help give me context and maybe help assign priority to this more vague IP address in a place, and I don't know too much about it, but the digital twin knows what it is, how long it's been there, knows where it can connect. It gives you a lot of initial context.
Sure, who's been using it, what it communicates with, where it communicates, how much it communicates, all that sort of.
Maybe even has DNS data as well. Right. That's kind of, so, and historical data on that too. You can imagine long time, very deep, and even very short depth data that's immediately useful for someone getting to the next step of whatever that alert or that ticket is telling them to do, possibly even telling them it's completely unnecessary to make the change. Right. Because the digital twin can say, well, is this a path that exists that you're asking for? And if the path exists, it can tell you, well, what are you doing? Right. This is one of our earliest use cases of firewall checker as a service, where a network team was so tired of all these stupid questions. They weren't stupid, right? They were well-meaning, but they couldn't be done without asking a team a question
sure.
because there was no exposed interface for them to go, hey, do I need this rule?
Right.
And so this deluge of questions that were often not really, connected to work that needed to be done
Sure.
was such a pain point for the network team that they built a web app with a custom digital twin that would look at the model and say, yes or no, is this needed or not? And then the moment it is needed, and you now have context from the user about exactly what they want.
Sure.
And so this was another customer that kind of built their own digital twin, but didn't want to manage this over time. And so they found that they could put those people to doing more automations and applications like this with those people on the network team if they replaced it. And so that is a use case you can do now. By asking the digital twin questions, it's going to become a lot easier. Next month, we're going to release our first agentic AI release where we'll support MCP servers as well as API calls to very easily plug in any ticketing system, really any general system, right? It's text
Sure.
in and it's text out to annotate and inform people.
That's good. I've been waiting for that for a
structure.
little while from you guys. Because what I really want to do
It
is,
is slated to come out
force a bidirectional automation of my change control process.
in the September release.
Awesome.
And then the follow-on that is part of the vision over time is to improve the ability for us to tell you, is this a high-risk change? What else needs to happen with this change? Is this change going to be complete? Because I think increasingly we're going to see systems that propose changes based on the history of what you've got in your network config or what the world has done
Sure.
for network config that propose something, but kind of getting back to AI without guardrails and can you trust this? You got to have guardrails. You got to trust that. You got to trust the data that's being used to make the, hey, this is what should change proposal. But ideally, you also can make sure that that proposal is correct, or even just babysit it while it's getting changed to make sure that it really did the thing that it was supposed to do. And so you can do did it do the thing it was supposed to do thing today. We have a concept of checks to verify that your network did change in the way that you expected,
Right.
that the state's in the right place, the connectivity's there, and that'll catch all kinds of errors like a vendor did a wrong thing, a vendor interface is incomplete, or it was just incorrectly specified and you didn't realize that till late. The next step beyond that, right, is the more proactive predictive that we hope to speak about more in the future.
Yeah, so exposure management, right? I kind of see it in a few different ways. Pre, post, and ripple, right? So pre, what exposure do I have that I'm unaware of? Right? What's likely to happen in the future that's going to cause me reputational risk? Post, this thing happened, I fixed the thing, but where else does it exist in my network? And then ripple, this happened to someone else, how do I know it won't happen to me?
Nice. I've never seen it posed as pre-post and ripple.
Yeah, I just came up with it. I hadn't either.
I like it.
I was trying to figure out in my head, like, how do I organize these thoughts? But pre, right? So I want to get ahead of it.
Yeah.
I want to make sure that I don't have a breach. So how do I do that? Post, I had a breach, I had an exposure, I had something happen. I fixed it in that system, but that really should bring up the question of, okay, well, if I had a misconfiguration here, I probably have a similar misconfiguration everywhere because we do things kind of similarly. And then third, I woke up this morning, there was a news alert, one of my competitors, somebody I'm paying attention to, whatever, they have reputational risk, this thing happened, how do I test for that thing?
I love this question, Howard, because it gets to the true value of a data platform and the life cycle of all the things that people need to do as CISOs, or in this case, more network operators and network security leads. So on the pre side, it's what do I have, which is a risk. So we have an exposure view on top of the digital twin. This was actually my Hack Week project a few years ago that we productionized. I literally worked with our designers for this because I had that problem that I knew, okay, well, we have these systems, but I want to track ones that are now exposed over time. And I want to make sure that the things that I see are filtered to what's real and what matters. And this is the general trend, right? Alerts should come to you only when they've only been filtered to what matters, ideally with no false positives and no false negatives. The beauty of a digital twin, which understands all these network paths, is that it's based on reality. It's based on math. And so there are no false positives where we say there's a problem, but there isn't. There are no false negatives where we miss the thing you wanted to find. Then the false negatives are the bigger worry because they mean you have unknown risks. So on the pre-side, both connecting the systems you have that check the vulnerabilities that you're aware of, or that the systems you know to check, and then their exposure is one. The other side of that is the network devices are often overlooked, and the vendors for exposure management typically don't focus on those, despite the fact that those are the least likely to get updated systems, and potentially you've fixed the 90% of the servers, and then the 10% of the network remains and puts you at higher risk. So because we see all the configs, and we see all the state, and we see all the feeds from the vendors now, we integrated that as a data source into our platform that we update daily for all customers. You can immediately see which vulnerabilities you actually have, and we can filter out the 90% that you just shouldn't care about because, while yes, technically the box has a vulnerability, your box running right now in your environment doesn't turn on the feature that puts you at risk. So the story for network devices, I think, with our digital twin is really unique, and it's only possible because of the depth of understanding we have, not just the version, but the configuration. The post side would be a problem happened, how do I get ahead of it in the future, and how do I understand the breadth of where that problem may currently be? This is what I call the I know I had it, now I need to find it, and I need to fix it forever, which means I need to represent that problem as a query.
Right.
I need code or a query that finds the problem and represents it on the snapshot of the network that I had before. Great thing is, because this is all, a digital twin can be a network DVR, you can go back and you can test your query. Like, you might have fixed the problem, but you want to go back and see, okay, does it find the thing I know it should find? And then you play it forward and say, okay, on the latest copy of the data, where else is it? There was a great use case that came from a federal government customer of ours here, where they had a problem that caused an outage, and it was traced to firewalls at the edge that weren't doing the same thing. And so you can map this to a query. You can say, for each of my firewalls, and we'll figure out based on the string and the name which ones are paired. Sure. Let's just make sure that all the rules are present, or even that the number of rules is the same in both. That's a good starting point. If we see differences, it means maybe the system that pushes the rules got slow, got out of date, it did an error, or maybe the configuration was never set up to enable this to happen. Very simple problem to describe in words. Very, very hard in practice, because you need to build a collection system that looks at all of your devices, because this could be on multiple different vendors that have this problem. You need to build a query system on top of that, and then you need to build a UI for this, and you need to maintain it until the end of time with the people you don't have, who have bigger, more important things to do, so they never get over the activation routine.
And you need to understand what has to be different, what has to be the same, so that you know what's actually out of date versus what's not really, or out of sync versus what's not really out of sync. If you just compare configs, there's a whole bunch of things that should in fact be different.
Config won't tell you if there's a problem. You have to have the config, and you have to have the state, and you have to merge the two. And that's exactly what Network Query Engine exists to do. Expose all the data in a way where you can do a query that looks at both at the same time and returns all examples of a violation. There's literally a violation called a true that you can filter on. So you can do both reports on what you have, as well as show me all the violations, and then you can turn those into automations down the line. You could maybe generate reports on those. You could potentially trigger automatic updates on some of those things as you get more sophisticated. And so this notion of, if you can identify a problem, define it with a query, you can find it forever, and you can get ahead of the problem. The other in that direction is, when you had some kind of incident, getting ahead of it means making sure that the problem that allowed it to occur, right, the misconfiguration in the first place, has been addressed.
But addressed everywhere.
Addressed everywhere. Right. So the first example is outage. We're talking about breach now.
Yeah. Right. I'm a huge multinational corporation. I have 800 endpoints in my organization from all the M&A that I've done, all the locations I have, everything. They get in through one endpoint. I need to make sure that the 799 others are also fixed.
This is where
very, very quickly
reachability analysis comes into play. So you can ask any question about connectivity, and you can ask a lot of questions very quickly, whether for automating or for asking these. Maybe our language doesn't define it in one check, but you can break it down into 10 or 20 or 100. It's great because they're all very fast to ask. So if you know what connectivity you're expecting, you can say, okay, well, here's how they got in before. Are they getting through after? And we actually recently added a feature that makes this direct in the interface. It's called a flow diff. So you can see what a flow did before as it came in, and how it got to that endpoint that got infiltrated, and then after, as it actually been closed off, and you can even turn that into a check. So you make sure it never gets exposed in that way again. And so that notion of, if you can ask a question about the path, very different question than the config and the state in a query, then you can turn it into something that you verify till the end of time, and you can check against all of the things that look kind of like that. So you can get ahead of that outage or that breach in the future by confirming that the fix you deployed actually has been deployed completely for that one instance, as well as you can find all the other instances of from here to there through this thing that eventually gets to a server of this type, right? And so you can define those all as tests that continually run. The third thing you asked about is kind of the ripple effect. Am I doing the things that my neighbors are also doing? Am I solving the problems that they've got? And again, this is where, if you can pose a query to check for something that someone else has seen, maybe it's one person in the world, one company experienced this problem. Ideally, every problem that anyone has ever solved gets solved for you automatically. And so we actually have what we call our forward community. Started out with Network Query Engine for exactly this reason, that we wanted a place where people could share their use cases, their stories, as testable queries, right? Here's this thing that identified all my firewall pairs that got out of sync, and I'm really scared of this because if one of those firewalls fails, which is inevitably going to happen, it means either an application can get disrupted or my security posture can be affected in a way that I don't understand, and that creates the conditions for someone to get in. And so the notion that anyone who uses our digital twin can share their query, or increasingly now, because we have AI query generation, can share the AI, share the prompt that generated the query, and then the query is reproducible.
Right.
The query is always going to do the same thing. So that's the other beauty, right, of an intermediate representation, that the thing you share is always going to deliver the same result, not a slightly different one if you mistype a word or the AI interprets it slightly differently over time. So that notion of getting ahead of the problems that others have seen is exciting to me, because this notion that every problem anyone has ever seen, I can get ahead of, that's how we should be thinking. That's the role that CISO should have, and they should have the tools that give them that ability to act on data in ways that are proactive.
So I love what we've talked about today. I'm a big fan of digital twins, right? Especially when they work and they have a workable ROI, right? They don't become a science project. The big things that I see are the potential versus the actual, right? We've talked a lot about the actual. We've talked a lot about today about what you can actually do today, right now, with network digital twin. What I'm really interested in is the art of the possible. What do we see in the future, right? Like I started to go down this path because theoretically I could apply any configuration change to the digital twin and see the effect of that, the dominoes fall within my network without actually doing it for real, and then come up with solutions to solve all of those unintended dominoes. Sometimes the dominoes are intended, sometimes they're not, right? I could create a zero trust overlay and say I want to apply the principles of zero trust to a network that's never had any thought around reducing the blast radius. And I could say, I want to reduce the blast radius. Here's the 5 applications I have that are my golden keys, my crown jewels, whatever you want to call them. I want to secure those to the maximum level of security that isn't present today, whatever it happens to be, right? I love the idea of, as we start to adopt MCPs, what if I had an MCP endpoint that looked like, in the virtual twin, that looked like the MCP endpoint for the actual device that I could hit first and do validation before it ever hit that other MCP server?
Yeah, I think the ability to predict the future and avoid undesirable outcomes is kind of a holy grail in networking that few researchers have attempted to solve, but is really a very hard problem. And I will say, I feel like the data in a digital twin is complete about your config, it's complete about your state, and it's just an amazing starting point for any progress in that future direction, that holy grail direction that we or anyone else atop that data wants to pursue. Because I'm excited by that too, right? The notion that your network could self-lock down, propose changes, and then make sure that those are actually safe ones for restricting access without disrupting anyone. Maybe you integrate other data sources to verify that.
Sure.
Like you look at what's with NetFlow. There was a great example. So Mike Winston at Fiserv is one of our public customers, likes to talk about his application. I talked to him personally a month ago about data center decommissioning as an application. And this is not as big and sexy on the surface, but it's really useful because this is a work that he has to do by a given time. They don't know all the applications, so they need to inventory them. They can figure some of this out from some flow data, and then they need to figure out what are all of those network rules that need to be changed and then replicated on another location so that they can move the app. And then they need to make sure and document that everything happened in the way that was anticipated, like it should have. Mm-hmm. And so it's on the surface, kind of boring and maybe not as exciting, but for the person who has to make that change,
you didn't notice, but when you said it, I went, ooh.
For the people who have the pain, it's exciting. Yeah. Even if on the surface, maybe it doesn't seem like the thing that automates everything, right? I didn't know that was possible until recently kind of thing. But those things becoming possible, those things are as exciting to me personally as the Holy Grail predict the future stuff that is still in the future today.
Yeah. Back in the day, I went through the WellPoint Anthem merger. 2 enormous American companies merging in a way that exponentially increased the bureaucracy, and getting any answer from anyone was impossible.
Splits and merges are the best possible use of digital kit
for that feature, because the number one thing you do in M&As is you try to figure out where are we super duplicative and how do we reduce the duplication so that we gain efficiency so that this whole experiment works.
What do we have?
And it takes forever.
And that process creates risk.
Yeah.
I know that process has led to major breaches where everyone had the best of intentions of finding synergies and decommissioning systems, but if you leave a default route and it points in the wrong direction, you've now created a bridge between your corporate and production networks. If that organization you just absorbed happened to have a guy who wanted an RDP instance exposed to the world before it was cool and didn't want the hassle of VPN, that's your problem now. How do you find these things early so that you haven't multiplied the risk of all the pieces as they combine and then create a new risk to add on top of it? It's a great use case, whether it's a split or a merge, because any change creates risk of outage, any change creates risk of breach.
Yeah, I also love it gets us over the stasis, right? Because we tend to go, these are all the things I know, and so I deal with all the things I know, but I know there's a bunch of stuff I don't know, and the time that it would take to know them is too long, so we stop for some amount of time. I don't care if you stop for a day, a week, a month, or a year, and it's more likely the year, but you just go, I can't get across the finish line to complete this thing. I'm at the 90th percentile. I'm literally, I can see, it's right there. You see the goal line right there, but I'm not confident enough to make that last step and turn it off.
I love it, and I want to generalize it a little beyond just the digital twin, right? Any system that gives us the data to solve a problem that we could not solve before. The problem's in sight, we see it in the distance, we know, we feel the pain today, but we can't get to that thing in the distance because we don't have the data, or we don't have the analysis on top of the data. That analysis is what potentially agentic AI can solve for us in a way that's pragmatic and scalable, in the sense that you don't need to add people coding and spending the time and incurring the risk. The core data is the limiter, and maybe we can end on this point, which I think is really powerful. Increasingly, if our role is to enable automations, our role is to deliver outcomes, to do more with less. We're only going to do better if we have the right data foundations. And so the systems that we invest in, the data that we have, whether it's curated by people, curated by machines, or a combination of the two, which is the realistic way, that is what will limit our ability to get better outcomes, to find efficiencies, to actually do things like prevent breaches and outages. And so I think every CISO, every CIO should be really thinking, and you had mentioned this in your chat with Nikhil a few weeks ago, that people should look about, that was a bit more agentic AI focused. We should know what good looks like, and we should write it down and work our way toward that. And we should invest in the systems and invest time and seek the resources really to get good data where it matters.
Well, on that, thank you so much. If you were paying attention, what you heard very clearly is CIOs and CISOs should pay attention to the things that they do to ensure all of them improve the quality of the data estate. Something I've been saying for weeks, months, long time is today is the day from now to the end of time where AI is the least useful, it is the lowest quality, it is the worst it will ever be. In order to stay ahead, to stay up, to gain momentum, requires really good data. So as you're making decisions, look for those decisions that improve your data estate, that enrich the data that you have available to you, and do it in a way that is trusted and manageable. Well, this has been awesome.
Same here.
So this was another episode of Discovering Disruptions in Tech. Please like, subscribe, follow, comment, share. If you'd like to be on an episode, reach out. We'd love to hear from you. Have a great day.